Let's look at the derivative of Cosx. These are some keynotes that we'll be using. So we'll start by labeling our function f of x as Cosx. The method that we're going to use to work out the derivative of Cosx is called differentiation from first principles. And the formula that we're going to use for that is here, which says that f dash of x, which is the derivative, equals to the limit as h tends to 0 of f of x plus h minus f of x all over h. And so using this formula, we now end up with the following. So f dash of x equals to the limit as h tends to 0 of f of x plus h. So in this case, that's going to be cos of x plus h. And then we have minus f of x. So in this case, that's going to be minus cos x all over h. And so this now becomes f dash of x, which equals to the limit as h tends to 0. And now we can use the addition formula for cos. So that tells us that cos of a plus b equals to cos a cos b minus sin a sin b. So in this case, we have cos x cos h minus sin x sin h. And then we have minus cos x. And all of this is divided by h. We can now write f dash of x, which equals to the limit as h tends to 0. And now we'll split this fraction into two separate fractions. We'll rewrite this as cos x cos h. And now putting this last term in front, we have minus cos x all over h. And then we can write minus sin x sin h all over h. Now in the next line we have f dash of x, which equals to the limit as h tends to 0. And now we can factorize out cos x from both of the terms in the numerator. So we now get cos x times cos h minus 1 all over h. Now in this term we have minus sin x times sin h all over h. Now using these small angle approximations in this line, we have f dash of x, which equals to the limit as h tends to 0 of cos x. And now we know that for very small angles, cos h is approximated as 1 minus h squared over 2. So we'll use that and we'll substitute that in here. So we get 1 minus h squared over 2 minus 1 all over h minus sin x. And now we'll use the small angle approximation for sine. So that tells us that sin h approximates to h. So we get h over h. Now simplifying this, we end up with f dash of x, which equals to the limit as h tends to 0 of cos x. And now inside this bracket, 1 minus 1 cancels. And then we have minus h squared all over 2 divided by h, which becomes minus h over 2. Then we have minus sin x, and now h divided by h is equal to 1, and 1 times sin x is just sin x. We can now apply the limit, so we have f dash of x equals to, and so we get cos x. Now applying the limit here, we end up with minus 0 over 2, and then we're left with minus sin x. Now, minus 0 over 2 simplifies to 0, and 0 times cos x is equal to 0. So we have f dash of x, which equals to 0 minus sin x, which simplifies to minus sin x. And so therefore, the derivative of cos x is equal to minus sin x.